Okay, I'm going to go over how to solve homework 8 for chapter 28. And so this is a circuits problem. So in this problem, I am given that my EMF, so my EMF 1, or I guess I'll just write just their symbol. So E1 is equal to 15 volts, and E2 is equal to 43.5 volts. My R's are given in the problem. So I have R1 and R2 are my internal resistance of the battery, 0.5 each. And then R1 is 6 ohms, R2 is 2.5 ohms, and R3 is 1.5 ohms. Okay, so this is going to be a long problem. What we're going to do is we're going to use the Kirchhoff's junction rule for current, and then we're going to use Kirchhoff's loop rule to go around the kind of the loop for each of these parallel circuits. So what I'm going to do first is I'm going to write down the Kirchhoff's, so I'm going to call it Kirchhoff's junction rule. And what this is going to say is I1 goes into junction A here, right? I have I1 goes into junction 1 and goes out to I2 and I3. So I'm going to write that as I1 is equal to I2 plus I3. Right, and by the way, the thing we're finding in this problem is we're going to find all the I's, find all the currents. Okay, so that's my first equation that I'll need. And now the next equation, what I'm going to do is I'm going to go around, I'm going to start at E1, and I'm just going to go around all the way here like this till I get back to B. So I'm going to start at B and I'm going to end at B. Okay, and so this is going to be the first use of Kirchhoff's loop rule. So I'm going to start at B, and so I'm going to say, okay, since I'm going on the negative side of the battery, so I'm starting at B and going to C, that gives me a positive E1, and then as I go around, I'm dropping voltage. So I know in this, I'm using I1 here, so I1 is the current all the way through till we get to E here. So I'm going to say minus I1 R1. And now I'm going to come back over here this way, and in this branch, I have, so this is I2, R1. And then this where R1 is, my current is I1, R1. And then when I get over here to R2, I'm going to have minus I2, R2. And when I get back to B, I'm at 0. So that is my next equation. And what I'm going to do is I'm going to combine the I2s. So I'm going to have E1 minus I2. And so both here, I have a minus before this one, and I have a minus before this one. So I'm pulling the minus out. So I'm going to get R1 plus R2 equals 0. And, oh, I forgot to add in that little part. So minus I1 R1 equals 0. And now I want to plug in my numbers, because usually I don't say to do this, but we're going to plug in numbers here. It just makes it a little bit easier. So let's just scroll up a bit. So my I1 is 15 volts. So I'm just going to write 15 minus I2. And now little R1 is 0.5, and R2 is, I think it's 2.5. Yep, 2.5. So that's going to be 3. So R1 is 0.5, R2 is 2.5, so the total is going to be 3 ohms. And then minus I1, and then R1 is, let's see if we look at that again. So R1 is 6. 6 equals 0. And I'm just going to now rewrite this one more time. So I'm going to say 15 minus 3I2 minus 6I1 equals 0. And that's going to be my second equation. So I'm labeling them, right? I labeled the first one 1 up here. That's going to be my first equation right there. And so this is going to be my I2. So I need an I3. And so what I'm going to do now is I'm going to go around. I'm going to start at E2, and I'm going to go around this way. And that's going to give me my third equation. So let's do that. So again, I'm going to use Kirchhoff's loop rule. So I have E2 starting at H. So I'm starting, say H is at 0, so I'm adding voltage from the battery that's going to be 43.5 volts, and then I'm subtracting the current here is I3. So I'm going to have I3 times R2 minus I3 times R capital 3, and then minus I1 times R1 gets me to 0. Let's just double check that. E2 minus, I think I miswrote this, so R2 has I3, and I still have I3 for R3, yep, and then minus I1, R1. All right, and so again, I'm going to plug in my values here. So that's going to be 43.5 volts minus, and now I've got I3, and it's going to be R2 plus R3, and then minus 6I1, 0. So 43.5 minus R2 is, let's go back, I think our little R2 is 0.5, but what is R3? 1.5. So that's going to be 2. Minus 2I3 minus 6I1 equals 0. Okay, so my next step is I've got 3 equations and 3 unknowns. So this is my third equation, right? And so what I need to do is use one of them to get some information about the other. So what I think I'm going to do is I'm going to plug in my equation 1 into equation 3. So let's look up here. I'm going to plug in I1 is equal to I2 plus I3. I'm going to plug this equation into equation 3. Let's just write that down. So plugging in I1 equal to I2 plus I3 into 3, equation 3. I get 43.7 or 43.5 minus 2I3 minus 6, and then I2 plus I3 equals 0. Okay, and so why did I do that? Well, if I look back at I2, at equation 2, equation 2 just has I2 and I1 in it. And so if I look at I3, I3 has I1 and I3 in it. So if I substitute in for, well, I probably should have done that a little differently. I think what I want to do is keep I1 in this equation. So I'm going to go back and erase that. I want to keep, I'm going to plug in, still using equation 1, but I want to keep I1, and I want to get rid of I3. Okay, so if I know I3 using 1 from 1, right, I3 is equal to I1 minus I2. So that's what I'm going to plug in for I3. So 43.5 minus 2 times I1 minus I2 minus 6I1 equals 0. Okay, so now I'm going to multiply through. So I'm going to have 43.5 minus 2I1 plus 2I2 minus 6I1 equals 0. And scroll, oops, do that. Scroll a bit. Okay, so I'm going to have 43.5 minus 8I1 plus 2I2 equals 0. Okay, so let's call that equation 4. And now looking back, if I look at equation 2, right here, I have an equation in terms of I2 and I1. So I'm going to write that down below. So 15 minus 3I2 minus 6I1. So 15 minus 3I2 minus 6I1. Okay, and I'm going to just rewrite this a little bit. keep the I1s together. Minus 6I1 minus 3I2 equals 0. And we'll just double check, just look at that again. So 215 minus 3 minus 6 minus 3I2 minus 6I1. Yep, okay, that looks good. Okay, and so this is just equation 2. So now what I want to do is I want to be able to eliminate one of these. And so what can I do? I need to multiply one equation all the way through by something so that the two equations, I can like have the same coefficient in front of either I1 or I2. So I think what I'm going to do is I'm going to look at the coefficients in front of I2, because if I multiply the top equation by 3 and the bottom equation by 2, then I will have 6I2 in both of the equations, and I can add them together and eliminate I2. So what does that mean? So what I'm going to do then is I'm going to multiply this by 2. And so when I multiply it by 2, I'm going to get 87. So 40 and 40 is 80, and 3.5 and 3.5 is 7. So I'm going to get 87. No, I need to multiply it by 3. Whoops. Let's see. 43.5 times 3. 130.5. So make that a 3. So I get 130.5 minus 24I1 plus 6I2 equals 0. Okay, and what do I need to do for the bottom equations? For the second equation, I need to multiply that by 2. So multiply this by 2, and I get 30 minus 12I1 minus 6I2 equals 0. All right, so just double checking. So 130.5 minus 24 minus 6, or plus 6, yep, and then 30 minus 12 minus 6. All right, that looks right. So what I'm going to do now is, because I have a positive sign here and I have a negative sign here, I can just add these equations. And what happens when I add them is this goes away. So I'm adding, so 130.5 plus 30 is going to be 160. 160. 160. 60.5. And then I'm adding these, so I'm going to get minus 36I1 equals 0. All right, so now I can get I1 alone, so I'm going to have 160.5 on this side equals 36I on this side, I1. So I1 is going to equal 160, so 160 divide 0.5 divided by 36. And I get 4.45, 4.46 amps. Okay, so 4.46 amps for I1. So now for I2, I can go back to one of these equations. So let's go and plug in for equation 2. So let's go right here and use this equation. And I'm going to plug in I1, and then I can solve for I2. So if I have, let's get I2 alone here. So I'm going to bring I2, I'm going to add I2 to 3I2 to both sides. So I'm going to have 3I2 is equal to 15 minus 6I1. And so I'm going to plug in, so that's going to be equal to 15 minus 6 times 4.46 amps. And then I2 is going to equal, so 15 minus 6. And I get a negative 11.75 divided by 3. Now, I got 6 point, so I get I2 is equal to, I2 is equal to a negative 6.08 amps. And then I3, I'm going to do the same thing. Actually, you know what I'm going to do for I3 is I'm going to use this equation where we plugged in. So I'm going to use this right here. So I1 minus I2, right? Oops, back down here. I1 minus I2. I'm going to have I3 is equal to 4.46 amps minus a negative 6.08 amps. And so it's going to be plus 4.46. I'm going to get 10.54. I3 equals 10.54 amps. And those are my 3 current values. Just a quick correction on the last problem. So this is not quite right. This is a negative 3.92 amps. So we're going to cross that out. This, or we'll just erase, actually. We'll erase that. And this is going to be 3.92 amps. And then if we go down here, let's erase this. And we'll erase that, fix that. So this is going to be 3.92. And then this is going to be 8.38. There we go.